Hello again and welcome back. In the last tutorial, we set up the JWT module to return an access token to us in the form of a JSON Web Token. Today, we'll learn how we can accept that token from a client application, verify that the token is indeed valid, and then extract its payload so that a user who closes their browser can rejoin a poll that they have left when they closed their browser window or the browser tab, and then reopen a tab to our application. As always, if you want to start along with this tutorial, you can go to my repository Ranker course, and then you can follow the instructions in getting started to clone or de-git the desired branch. We're on tutorial 7, so you would just go up to master and find the name of the 06 tutorial branch here. Let's review our existing endpoints inside of our polls controller. So let's open up our server and go to the source folder, and under the polls folder or feature, we'll access polls.controller.ts. In the controller decorator here, we define a path or base path of this API, which will be polls. And as it stands, we have some endpoints for the root polls. You can see we have an @post decorator here with no string inside. That means if we post to the polls path, we will call this create method, which will call our poll service to create a poll. We also have a post/join. So if we post to polls/join, we'll call the join poll service method. And then we have this rejoin poll where we didn't actually end up accepting any information from the request. As you can see in this post, we have an @body decorator to accept the incoming JSON from a post request, and likewise in the join endpoint. However, in this rejoin endpoint, what we want to do is accept a JSON Web Token that we will have issued via the first two endpoints, and then extract the user's poll ID and maybe their name and user ID from that token to then request to rejoin the poll that they might have accidentally left. I now want to review what happens when we post to the polls controller here and when we post to /join, just to drive home what's actually happening. And to do that, let's start the application with npm run start. And then once this boots up, I will start Postman. Okay, I'm here in Postman, and I have a tab here created for creating a poll, and you can see that it uses the base URL, which I've just defined as a variable at localhost 3000. That may be hard to see, the font's a little small, sorry about that. And we will post to /polls, which is the root endpoint with this data about the topic of the poll, how many votes each player or participant gets, and this initial voter's name. Let's send. And you can see that we get back the full poll. Now notice that this user isn't listed as a participant yet. That's because we'll add them as a participant when their WebSocket connection initiates. Then they get back this access token. And this is the access token that a client would use to rejoin the poll if they perhaps leave, because it stores within this base 64, it stores the user's name, their ID, and the poll information. Let's just show that we can join a poll, and let's get this poll ID. I think it's BQ, there it is. I probably have a script to save this poll ID. Here it is. So basically in create poll, once I get this poll response, this ID, if you go to test scripts here, there's a little way in Postman, just a tip, where I can set an environment variable from the last response. So that last response returned a poll ID, and it returned an access token, and I store those in poll ID and token 1. I store it as token 1 because I've kind of have a setup for multiple players to join a poll, which will be useful later on for testing the API. With that said, let's go back to join player 2, and you can see that they will join with poll ID here, and they will also get an access token with their relevant information. And so these access tokens are what will be sent back and extracted and used to rejoin the poll. I hope that's clear. I've said it about 17 times. Before we go too far into building our authorization guard, as it's called, you can check out this nice page on guards and overview guards in NestJS, which will give you an idea of how they work. But let's go on and build ours directly. I could put this guard outside of the polls, but we're really only going to be using this one for a poll, and our token has poll-specific data. Therefore, we'll add it here in the source/polls folder. And we'll call it controllerauth.guard.ts. And let me close this. I think that's Command J. Okay. To initialize the guard, I'll put a little bit of code in here and explain it. We'll import some things from NestJS Common. Importantly, right now, are injectable. And remember, injectable makes it so that a certain class, in this case, our controller auth guard, can be provided to other services. And then we're going to bring in the canActivate interface. We'll use this execution context and forbidden exception later on. We're also going to import our JWT service, or actually the JWT service provided by NestJS, and the logger. In fact, I don't know why logger is on this line. It's the same import. We'll add it up here. As I mentioned, we are bringing a class that implements canActivate, and this is an interface which allows a class to become a guard. And in order to do that with interfaces, we have to implement certain functionality on the interface of canActivate. If I go to the controller guard and hit Command period or whatever it might be in your IDE, they often have a little tool or helper to implement interface canActivate, which will bring in the methods and properties you need for the implementation of canActivate. If we do that, and I'll add a little space here, we can see that canActivate takes an execution context, and then it will return a Boolean, a promise of a Boolean, or an observable of a Boolean. In our case, we're not working with observables, so I can just remove that. And this should still be able to work. And right now, it just throws an error saying that the method's not implemented. If I save, I add the little space at the end of the file. And what this canActivate does is if we return a true or a promise that returns true or resolves to true, then this controller or guard will allow us to proceed on. Otherwise, the guard will block. And so what this does is it sits in front of our controller endpoints that we choose to apply this guard to. And if someone doesn't have a proper JWT, then it will block them from proceeding and throw an error or return false. In our case, we're actually not going to return false, but we are going to throw an error. Let's go ahead and start implementing this. So you'll notice that we have this context of type execution context. And so what we can do now is tell NestJS that this context or this guard is going to be used on HTTP controllers. We can also do a context switch to WebSockets method. And this basically just tells us that the incoming request is coming from a REST API. And then we use getRequest to get the request on the HTTP incoming request. I guess that was redundant. Then we're going to do a little bit of logging to just show that we're checking the auth token that's coming in on the request body. Often these auth tokens will be brought in on a header, but in our case, we're just going to send it in the JSON body. Before moving on further, I want to add some utility functions inside our types.ts, or I should say more like utility types. And this is just going to define the shape of our request that's going to be used by our controllers, because we're going to mutate the request body and we're going to add some authorization data in it, namely the user ID, poll ID, and the user's name. To do that in types, I'm going to import up top the type of the incoming request, and this happens to be coming from the request from Express. Now, actually, we could probably honestly use the NestJS request here, so I'm going to actually do that. All right, I had some typing issues there, but I have imported request from NestJS common. And then we're going to go down and define sort of the payload we want to merge with the standard request properties. We're going to define an auth payload that again has those fields that will be extracted from the token. And then beneath this, we're going to create a type that is the request joins sort of with the auth payload. What this does in TypeScript, the ampersand, is it merges the fields of the request with those of the type of the auth payload, or the interface if it were for auth payload. Let's save this and go back to our controller. What we're now going to do after we have this little login message is we're going to extract the access token from the request body. And this is that request body that we're going to be getting here, or this is the request and we'll extract its body field. And then we're going to take this access token and we're going to verify that the JWT is still valid using our JWT service, which we injected in the constructor, which was added to our polls module if you want to look at this file. Let's get rid of this return false here. And actually, we're going to add this inside of a try catch block. So let's move all of this into a try statement. What we're going to do is use that JWT service provided by the JWT module to verify that the access token is valid, which means it hasn't expired. You may recall we set our tokens for 2 hours, and this also makes sure that someone hasn't changed the payload fields like the sub, poll ID, and name in the token, or in other words, that it has not been tampered with. If this fails to verify the token, the way this works is it throws an error, so we will catch that error. And we're not actually going to use any data on this error, but we will throw a forbidden exception, which is provided by NestJS, and you can see I have that here, but it's unused. And let's add this in the catch block. And the forbidden exception, as you can see here, is just for an authorization error or an error of type 403 in HTTP parlance. So let's save this. I think I have some formatting issues. I guess I don't need these parentheses if I don't have the error. And then up top, I have an unused import. Let's get rid of that. And that is all for our auth guard. Now, how can we apply this guard? We'll do so on the individual controller methods, although you could also apply an auth guard to all methods on a controller. And we do this via a useGuards decorator. So let's go back to pollscontroller.typescript. And let's then go to the endpoint we want to use this on. Remember, that is the rejoin poll endpoint or path here. So let's now say @useGuards, and let's import this from NestJS common. And we're going to apply the controller auth guard, which is the name of that class we just made. And so this is great. That means that this rejoin method is now going to have access with a request. If we go back to controller auth guard, you'll notice that we took the request and we added the user ID, poll ID, and name to it from the JWT payload. Now remember, maybe this wasn't clear, I kind of went over it fast. We defined in types that we could have a request, a normal NestJS or Express request, and then we merged it with the user ID, poll ID, and name. So now if we define this request with auth on our controller coming in, we'll have full typings for it. So let's do that. And we do it with the @rec decorator for request, and that is from NestJS common. And let's call that as a function, and we'll call it request. And remember that type is called request with auth, and we'll import that from /types. So now all we need to do is replace this dummy data on the right-hand side of this object that we're calling rejoin poll with the actual data from the request. So what I'll do is I'll use a little destructuring here. and we'll say user ID, poll ID, and name extracted from the request, or which is request from auth. And then we can just sort of get rid of this extra data and use object shorthand. And so now we should be able to rejoin a poll with a token. So let's go ahead now and demonstrate this. To demonstrate, I'm going to open my terminal just to show that the application is still running. And you can see it's been auto-saving. I just used Command J to pop open the terminal. And I also will have Redis Insight v2 open. And you can see that here. And let's open our ranker poll. Let's refresh. So far it's empty. And then we'll use Postman to first join a poll and then rejoin it with our token. So here I am, and I'm first going to go to create poll. And remember that this has some body, maybe player 1. We'll send the request, and that's great. And then we'll join with player 2. And remember, I'm using a variable with the poll ID. That in create poll, I extracted in tests here. And so player 2 will join the poll. And what I can do now is take their access token, and I'll just copy this. In fact, I might be scripting and saving this access token. Let's go to tests here. It looks like I'm saving this as token 2 for joining as the second player. And let's go to rejoin poll. And an access token now in the body, I'm going to send that token to. I think if I hover, well, I guess it's not going to show it, but that should be the value of the token we just saved. And let's send this. And you see that we get the information about the pullback and even the admin's ID. And if we go back to Redis and click refresh, we can see that the poll is here, and we can see that this user, player 2, has rejoined. Now, this is a little funky. You'll say, why isn't player 1 in there? That's because the initial connection I wanted to use via WebSockets, and I just wanted to show a different method of joining and getting fresh poll data with the REST API. And when we work with the client, that will become a little clearer. I admit it's a little odd, but I hope you see that this is working. Next time we'll get going on building out some WebSockets using NestJS. Take care.